This is Dr. Brown. I'm going to work quiz 4 version 1. The first problem, you want to use a finite approximation to estimate the area under the curve of y equal x squared. First thing, and we're to use two upper triangles. The first thing you want to do is draw a graph of y equal x squared, which looks like this. And we want to use two upper rectangles. So labeling the x-axis, this would be 1 and this would be 2. This would be 0. The value of the function at x equal 1 is 1, so the height of this rectangle would be 1. The value of the function at x equal 2 is 8. I'm sorry, it's 4. And so the area would be 1 times 1 plus 1 times 4 equal 5. That would be answer D. For version 2, it would be A. Problem 2, we want to do this summation for k equal 1, 2, and 3. So we're going to put k equal 1, 2, and 3 into this expression and sum them up. So we will get 6 to the first power sine of pi over 6 plus 6 to the second power sine of pi over 6 plus 6 to the third power sine of pi over 6. And of course, sine of pi over 6 is 1/2. So we'll get 3 plus 36 times 1/2 is 18 plus 216 times 1/2, which is 108. So the sum is 129, and that is answer D. For version 2, the answer was A. Next, we want to do a very simple integral. And of course, we want to take the antiderivative, which in this case is 4x to the 4th over 4. From minus 3 to 5, that would be equal to x to the 4th between minus 3 and 5. And substitute 5, and then substitute minus 3 and subtract. Always insert the top value first, and that will give you 625 minus 3 to the 4th power, which is 81. So the answer is 625 minus 81 equal 544, and that is answer B. For version 2, it would be A. Next problem, find the total area between the curve and the x-axis. Drawing a graph of the function between z and 0 and 2, sort of like this, and we'll find this area. So the area is going to be the integral from 0 to 2, 2x minus x squared dx, which will be x squared minus x cubed over 3 between 0 and 2. And that would give us 4 minus 8/3 minus 0 minus 0. That equals 4/3, which is answer A. For version 2, it was answer D. Next, we want to evaluate this integral. I suggest using a substitution, and the substitution that's appropriate here is u equal x to the 6 minus 4 du dx is equal to 6 x to the 5th du is equal to 6x to the 5th dx. And we can see that x to the 5th dx is equal to du over 4, du over 6. And therefore, x to the 5th dx is equal to du over 6. And the integral becomes, after we do the substitution, u to the 4th over 6 du, which is u to the 5th over 30 plus a constant. Then substituting in for u, you get x to the 6 minus 4 to the 5th power over 30 plus a constant, which is answer C. And for version 2, it would be A. The next problem is to find the derivative of this integral. And remember the fundamental theorem of calculus, which I call version 2. It's just plain old x up here at the top. And we're going to substitute that everywhere we see a t. And we get that y prime equal dy dx equals the square root of sine of x tangent of x squared. And that is answer B. For version 2, it's D. Problem 7. Similar to the first one, except now we have a g of x for the upper limit instead of just plain old x. So we need to remember the chain rule. So we're going to substitute x cubed everywhere we see a t. And so we get sine of x cubed plus ddx of the function x cubed. And so this gives us 3x squared sine of x cubed, which is answer D. For version 2 is answer A. The next problem is to find the area of the shaded region. This area, of course, would be the integral from 0 to 3 of x squared plus 3 dx equal x cubed over 3 plus 3x. Evaluated between 0 and 3. I'm sorry, 0 and 2. Have to put the correct upper limit. And of course we get 8/3 plus 6 is equal to 26/3, which is answer A. For version 2, it would be B. Problem 9. We're told that the area of the region between the graph of a positive continuous function f and the x-axis from x equal a to b is 6 square units. We can draw, say, the function from a to b over here, and that is, no matter what it looks like, is 6 square units. And we want to know the area between the function f of x and y equal minus f of x. And that would be, if I can draw it upside down, minus 2f of x, or I'm sorry, minus f of x. And this area would be minus 6. And so the area is going to be 12. So the answer is D. For version 2, you had to find the area between f of x and minus 2f of x, which would have given you a 6 and a minus 12. And so the total area would have been 18. That would have been answer A on version 2. Now problem 10. We're told that the function f has a negative derivative for all values of x. So f prime of x is less than 0. And f of 2 is equal to 0. And we want to find out which one of these statements about G is true. We're looking at possibly local minimum, maximum, inflection points, or where it crosses the x-axis. Well, as you know, to find out things like that, we would want to take the derivative of G, and for possible inflection points, or for looking at whether the function is concave up or down, we're going to take the second derivative. Well, looking at G of x, using the fundamental theorem of calculus, we will say G prime of x is equal to, replace with x, everywhere you see a t, so G prime of x would be f of x. That means G prime at 2 equal f at 2 is less than 0. So we know that G could possibly look like this, or it could look like this, or it could look like this at x equal 2. So to find out which one, we're going to take the second derivative of x. which would be the first derivative of f. And that means that g prime at 2 equal f prime at 2. And we're told that the first derivative of f is less than 0. That means it's concave down. So it's looking like this, so it's a relative max. So the answer is B. Local maximum at x equal 2. For version 2, the answer was A. And this problem, we're going to find the area of the shaded region. So the area is going to be the interval from 0 to pi over 6, pi over 4 of secant squared of x minus cosine of x dx. For this, we want to calculate the antiderivative of secant square of x, which is tangent of x. The antiderivative of cosine x is sine of x, so this would be minus sine of x from 0 to pi over 4. We now get tangent of pi over 4 minus sine of pi over 4 minus tangent of 0 minus sine of 0, parentheses. These values are 0. Tangent of pi over 4 is 1. Sine of pi over 4 is the square root of 2 over 2. So we get 1 minus the square root of 2 over 2, which is answer B. Version 2 would be A. And we want to use the substitution method to evaluate this interval. Well, if we set u equals sine of x, we see that its derivative, du dx, equals cosine of x is right there in the integram. So this sine of x dx would be du. And we then would have 3 square roots of sine of x, which would be the square root of u. And we now need to be careful and change the upper level or upper limits of x to upper and lower limits of u. So the upper u would be equal to sine of pi over 2, which is 1. The lower u would be sine of 0, which is 0. So now we have to do this interval. This would be the integral from 0 to 1 of 3 u to the 1/2 du is equal to 3 u to the 3/2 over 3/2 between 0 and 1. This is equal to 2 square roots of u, 3 cube roots of 3 square roots of u cubed between 0 and 1, and of course this is just going to be 2, which is answer A. So version 2 would be D. Problem 13, we're told that the integral from 1 to x of f of t dt is sine of x plus ln of x. We want to find f of x. What we do here is realize that if you take d dx of the integral from 1 to x of f of t dt, that's equal to f of x. So if we take the derivative on the other side, which is derivative of sine of x plus ln of x, f of x would be equal to cosine of x plus 1 over x. And that is answer D. For version 2, it would be C. Problem 14. Notice we have an inverse sine of x, and we also see its derivative there. So we would let u equal inverse sine of x, and du dx is 1 over the square root of 1 minus x squared. So du is equal to dx over the square root of 1 minus x squared. So this portion of the integral would be du, and since inverse sine of x equal u, we would get the integral of u to the 4th du, which is u to the 5th over 5 plus a constant. And then substituting for u, we get inverse sine of x to the 5th over 5 plus a constant, which is answer B. Version 2 would be C. Now we have a problem finding the definite integral from 0 to 1 of this function. Notice if we let u equal 16 plus 3 r squared du dr is equal to 6r. So du equals 6r dr. So 6r dr would be du, and we would now have du over the square root of u. Changing the lower and upper limits by putting r equal 1 in the equation for u. The upper limit would be 19, and replacing 0, we get 16. So we have the integral from 16 to 19 of u to the minus a half du equal u to the 1/2 over 1/2 between 16 and 19, which is 2 square roots of u between 16 and 19. So we get 2 square roots of 19 minus 2 square roots of 16. And this, of course, is 2 square roots of 19 minus 8, which is answer D. Version 2 would be C. Problem 16. We need to find the area shaded here. Notice part of the function is below the x-axis, and we need to find out the place where the curve intersects the x-axis. This is x cubed minus 4x equal x times x squared minus 4 equals 0, so x equals 0, and x equals 2 would be the 0 we're looking for, so this point is 2. So to calculate this area, we need to take the absolute value of the interval from 0 to 2 of x cubed minus 4x dx plus the absolute value of the interval from 2 to 3 of x cubed minus 4x dx, because the second interval is going to be positive. And what we get is x to the 4th over 4 minus 2x squared between 0 and 2, and the absolute value of that, plus the absolute value of the antiderivative is also x to the 4th over 4 minus 2x squared between 2 and 3. And we get, substituting 2, we get 4 minus 8 plus 81/4 minus 18 minus, plugging in the 2, you get 4 minus 8, and the absolute value minus 4 is 4. You get 81/4 minus 18 minus 4 plus 8. This all becomes 81/4 minus 10, which becomes 41/4, which is answer A. Version 2, it would be D.